Hello, everyone. I'm Madhan Kumar Vasudevan, shortly Madhan, working as a postdoctoral research fellow with Professor Marianna Obrist at the University College London. First, on behalf of all the authors, I would like to thank the CHI committee members for giving us the opportunity to present our work at this prestigious venue. Our title today is about MindTouch, which is a study to understand the effect of mindfulness meditation on mid-air tactile perception. Now, when I say mid-air tactile, it means the tactile stimulation delivered using ultrasonic phase array and without being in contact with the human skin. We are in the era of ever-growing user interface technologies. So it is essential to focus on the user while we improve the capabilities of the user technology. Here at UCL, our group develops multisensory interface technologies with a special focus on touch, olfactory, and gustatory sensations. We believe that these sensory experiences in HCI can be improved if we focus on the human sensory perception and the attention regulation while we improve on the technology. In this work, we used guided mindfulness meditation as a tool for regulating the attention. By enhancing the perception, we believe that the user can have effective and confident interactions, pushing the technology into more complex applications. The mid-air haptics is an emerging technology that can provide contactless tactile stimulation while using ultrasonic phase array. If we use modulation techniques, the acoustic radiation pressure generated by the array can be felt by the non-hairy skin regions of the body, which are densely innervated by the mechanoreceptors such as rapidly adapting and the Pacinian mechanoreceptors of the touch. However, since the maximum tactile force generated by this acoustic radiation is much lower than the contact-based haptic stimulation, this mid-air haptics is limited in various applications, specifically where the information transfer or communicating an information is involved. In this work, we considered a simple study where we measure users' performance on tactile character recognition. Here we use digits from 0 to 9 as characters. These characters are drawn on the palm using ultrasonic focal point. We know that this focal point is vibrating at 40 kHz, which is not perceptible by the human skin. So we amplitude modulated the focal point to a much lower modulating frequency, let's say around 100 Hz or 200 Hz, compared to the ultrasound so that it is perceivable by the skin. So this is how we drew the numbers. As you can see, the style, the solid dots represent the start point and the larger arrows indicate the end point. Except the digit 4, which needed 2 strokes to mimic the handwriting style, the other digits were drawn using single stroke. We drew at the drawing speed of 10 centimeter per second and at the elevation of 20 centimeter from the mid-air haptic array. Also, we used 2 different modulating frequencies with an attempt to stimulate 2 different mechanoreceptors of the skin, namely the RA receptor and the PC receptor, one at 40 Hz and the other at 200 Hz respectively. As for the study, we had 2 within subject conditions, which we call as baseline and mindfulness conditions. The mindfulness is where the participants perform the recognition task following a 10 minutes mindfulness meditation, which is audio guided. And the baseline condition is the same task without the meditation session. We made sure that there is at least 24 hours gap between the 2 conditions. Here is a user interface provided just for visual interactions, and the participants were asked to tell the response orally while the experimenter recorded their responses. So the responses include the choice of digit and the confidence of their choice. There were a total of 22 participants attended both the conditions. So in total there were like 10 digits, 2 different frequencies, and then each stimulus were repeated 3 times. So we had total of 2640 responses recorded along with their response time. We also recorded the heart rate and asked the participants to fill the questionnaires regarding the mindfulness meditation, which we followed the Toronto Mindfulness Scale questionnaire. So all the responses were put together in a confusion matrix to observe the overall tactile character recognition performance. We observed that the digits 9, 3, and 5 were most difficult and had poorer performance, while digit 1 was easier to recognize. We also asked simple questions during the study about the sensitivity on various regions of the palm, and we visualized in the order of decreasing sensitivity, which is shown here. And as you can see here, the lower part of the palm is the least sensitive, and the upper region, like right below the fingers, they are more sensitive. Here are the performance of participants in digit recognition task at different conditions, namely the baseline and mindfulness conditions. The left figure shows the true positive rate, and the right one shows the response time recorded between the time in which the stimulus is delivered and the response was recorded. So the performance at mindfulness condition was significantly higher than the performance at baseline condition. Also, in the mindfulness condition, the participants were able to respond quickly. We observed similar results at two different frequencies as well, with performance at 200 Hz is significantly higher than the 40 Hz signal, which means that the stimulation which was delivered at 200 Hz was more perceivable or more recognizable when compared to the stimulus or the numbers drawn at the frequency of 40 Hz. Now, there could be many reasons for this improvement in the performance. However, a prolonged mindfulness meditation study will give us something called through the looking glass experience of unexplored sensory experiences. Based on our observation, I would like to summarize saying that we believe that there is a potential that the mindfulness can make a difference by placing the user into a more adequate state to use the haptic interfaces, and thereby the proposed study can be extended to check perception involved in other sensory modalities, leading to mindfulness multi-sensory experience. Thank you everyone for listening more mindfully today, and as a final note, I would like to again thank the CHI committee members for this opportunity, and I would like to thank University College London for providing us the facilities, and this work is fully funded under the Touchless European Union project. And thank you all.